Hello, my name is Bhanu Prakash. I'm EC from section C. Today's my tech talk topic is cross noise crosstalk noise budgeting for PCB layout. Introduction to crosstalk noise budgeting. Crosstalk noise budgeting is a systematic approach to managing the electromagnetic interference between PCB traces. Crosstalk noise budgeting is a systematic approach to managing electromagnetic interference between PCB traces. It ensures signal integrity by predicting and mitigating unwanted coupling effects. Means unwanted effects of electric properties. Proper budgeting is critical for high speed digital and RF PCB designs. What is crosstalk in PCB layout? Crosstalk refers to the unwanted electromagnetic coupling between adjacent PCB layout. What is crosstalk PCB layout? Crosstalk refers to the unwanted electromagnetic coupling between adjacent traces. It can cause signal degradation, timing errors, data corruption. Understanding the mechanics of crosstalk helps in designing more robust PCBs. PCB layout. For proper budgeting is critical for high speed digital and RF PCB designs. What is crosstalk PCB layout? Crosstalk refers to the unwanted electromagnetic coupling between adjacent traces. It can cause signal degradation, timing errors, data corruption. Understanding mechanisms of crosstalk helps in designing more robust PCBs. Types of crosstalk. Capacitive crosstalk occurs when due to electric field coupling between traces. Means electric fields are interfered between two traces in the same PCB, which causes disturbances in electricity. Inductive crosstalk results from magnetic field coupling. Both types occur simultaneously, affecting signal integrity differently. Factors influencing crosstalk. Factors are the traces of the significantly impacts level of crosstalk. Means electric fields significantly impact the coupling between two traces in the same PCB layout. Inductive crosstalk results from magnetic field coupling. Inductive crosstalk results in magnetic field coupling. Both types can occur simultaneously, affecting signal integrity differently. Trace spacing significantly impacts the level of crosstalk. Signal rise time and frequency determine the susceptibility to coupling. PCB dielectric properties and layer stack-up also influence crosstalk behavior. PCB dielectric properties are the layer and layer stack-up also influence crosstalk behavior. Goals of crosstalk noise budgeting. Goals of crosstalk noise budgeting means the primary goal is to quantify acceptable crosstalk levels within design specifications. Means the crosstalk levels in the design means distance between and acceptable electric fields should be maintained in the crosstalk within design specifications. Means according to the design it should not be involved with other loopholes. The primary goal is to quantify acceptable crosstalk levels within the design specifications. It helps allocate noise margins across different signals. Effective budgeting guides the placement, routing and shielding strategies. Means it helps in routing, means locating in which direction it should move and what are the operations it should perform. And shielding strategies means the distance that the two traces electric field coupling should not be affected by each other. Shield in which we use shielding strategy. And next, components of crosstalk noise budget. The budget includes maximum allowable coupling noise for each signal. Means maximum noise that can be compensated for each signal. It considers the coupling mechanism, geometrical factors and operational parameters. The budget serves as reference throughout the PCB design process. Means the budget should be limited and very compatible with the PCB design. Define signal requirements. Identify critical signals that are sensitive to noise or can cause interference. Signals can be interfered with other signals. Many signals like say radio signals, phone signals can be sometimes interfered with other signals because two of them are of same frequency. Determine timing, voltage, data integrity requirements. Establish acceptable crosstalk levels. Establish acceptable crosstalk based on system specifications. Analyze coupling mechanisms. Evaluate proximity orientation of traces of assess potential coupling. Use electromagnetic simulation tools to predict crosstalk contributions. Means simulation tools which are used in crosstalk or PCB designs are simulated into the computer software, which simulates the amount of traces, electromagnetic field and coupling. Means the traces of electric field should not be should not be cross should not be crossed out, should not be cross border. Electric field coupling should not be interfered. And consider the effects of differential pairs and ground shielding. Now set noise budget limits. Assign maximum crosstalk levels for each pair on sensitivity. Means once we simulate every pair of crosstalk levels, we then incorporate safety margins to accommodate manufacturing variations. Means while manufacturing there should be a safety margins in different types of PCB designs. Document these limits as part of the overall signal integrity plan. Means signal should not be interfered with other signals, overall signal integrity plan. Implement design strategies. Increase trace spacing for high speed or sensitive signals to reduce coupling. Use ground guard traces. Means at the ground of the PCBs there are these boards and these operating systems which shield from guard traces. Ground guard traces means electricity is moved in this crosstalk. Optimize routing paths to minimize parallel runs. Coupling dense. Optimize routing paths means reduce the number of paths as less and minimize parallel runs. Means parallel task. In a PCB there are multiple tasks are going on in which we just use a single task. And verification and adjustment. Use signal integrity simulation tools to verify crosstalk levels against the budget. Adjust routing, spacing, shielding as needed to meet the limits. Iterate the design process until crosstalk budget is satisfied. Means the design should be as measured as in this integrity simulation tools. Integrity simulation tools are needed. Integrity specification means integrity simulation tools like PCB designs. PCB designs are used. Simulation tools are used in for the PCB designs for the testing of the designs and adjust routing and spacing. At the adjusting routing means adjusting the signals which are passing through the PCB design. Commands. Spacing means spacing between how much task in the given time should be completed. Meet the limits. Shielding as needed to meet the limits. Iterate the design process until the crosstalk purchase is satisfied. Practical tools for crosstalk budgeting. Electromagnetic simulation software such as HFSS or CST helps predicting coupling. Electromagnetic simulation software PCB CAD tools with built-in crosstalk analysis features facilitate budgeting, measurement and testing on prototypes. Validate the effectiveness of mitigation strategies. Measurement and testing on prototype validate the effectiveness of mitigation strategies. Best practice PCB tools for built-in crosstalk analysis. Facilitate budgeting. Best practices and design tips. Maintain consistent tray spacing and proper layer stack up to control coupling. Use differential signaling to reduce susceptibility. Keep high speed and sensitive signals away from the noisy power or clock lines. To reduce the high speed and sensitive signals from noisy power or clock lines, we should do enough spacing between the two traces of electric fields. Conclusion. Crosstalk noise budgeting is essential for ensuring signal integrity in high speed PCBs. A systematic approach helps identify, quantify and mitigate coupling effects. Combining proper design practices with simulation tools achieves optimal PCB performance.